Hello my dear children, welcome to the mathematics class. Today we are going to discuss integrals. In this chapter we are going to discuss the sums in the exercise 7.2. In the exercise 7.2. Okay my dear children, page number 304 in the textbook. Page number 304 in the textbook. Are you ready to listen the class, my dear children? Right. In the previous class, we have completed 5 questions. I hope you have learnt well. Okay, my dear children. Now come to the question number 6. Question number 6. Integrate square root of ax plus b. Integrate square root of ax plus b. Okay, my dear children. Right. Now come to the solution part. Let us assume that capital letter I is equal to integral square root of ax plus b dx. Understood this first step, my dear children? Right. In general, the functions under the radical sign also can be taken for the substitution. That is also one of the technique. Okay, my dear children. Not always. It is also not a general rule. According to the question, we have to take the part of an integrand. The part of the integrand should be taken for substitution. So here under the square root sign, ax plus b is there. So let us take ax plus b for substitution. Okay, my dear children. Put ax plus b is equal to t. We have taken this function for substitution. Okay, my children, understood this step? Right. Now we take the differentiation. We have to take the differentiation of the on the both sides of these functions with respect to t. Differentiating with respect to t. This implies what we will get here. I am writing the steps here directly. What is the derivative of this term? A. Isn't it or not, my children? A. Plus, what is the derivative of this term? It is constant. So, its derivative is 0. Into dx by dt. Like this, we have to practice. Okay, my children, directly. Not step by step. Okay, my children, is equal to. Here, what will get d by dt of t? 1. Understood this step, my children? I wrote here direct step. Okay, my children? So, if you want to find derivative of this function with respect to t, do it in a rough work. You get the same. Okay, my children? Right. From this equation, let us find the dx value because there is no a dx. So, we find dx only. So, dx is equal to dt by a. Isn't it or not, my children? We are transposing a by dt to RHS. Then it becomes dt by a. So, we got dx value. Here we have taken ax plus b equal to t. So, we substitute these two values in the given integral. Okay, my children? Right. Therefore, I is equal to integral square root of what is x plus b is taken? T. So, t. This part is over. Now, what is there here? Dx. What is the value of dx here? dt by a. Understood this step, my children? Right. In this integrand, 1 by a is a numerical coefficient. We write it before the integral sign. So, 1 by a integral root t can be written as t power 1 by 2. T power 1 by 2 dt because root a loss of exponential radical sign to exponential form. This is called radical function. This is called exponential function. By using this result, we wrote this term. Understood this step, my children? Right. Now, if you observe this integral, the given integral reduced into the standard integral. Which integral? This one. Yes. Integral x to the power of n dx. It is in the form of integral x to the power of n dx, where x is equal to t and n is equal to 1 by 2. Okay, my children, understood? That is equal to 1 by a t to the power of 1 by 2 plus 1 by 1 by 2 plus 1, because integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. By using this formula, we wrote this step. Understood this step, my children? Right. Integration part is over. Now we have to simplify. We have to write the value in the simplest form. Okay, my children? Right. This is equal to 1 by a t to the power of 1 by 2 plus 1. What will you get? 2 ones 2 plus 1, 3 by 2. By in the denominator also we get 3 by 2. Understood this step, my children? We are simplifying. We are writing this function in the simplest form. Understood this step, my children? Right. That is equal to, after this step I am writing here continuation. 3 by 2 is there in the denominator. We write its reciprocal, that is 2 by 3a, 2 by 3a. Understood this part, my children? Into t to the power of 3 by 2 into t to the power of 3 by 2. We wrote the given function in the simplest form, but here we got the answer in terms of t, but the given function is in the variable x, so we have to convert again this function into variable x. What is the t here? Ax plus b. So we substitute that value again. That is equal to 2 by 3a ax plus b whole to the power of 3 by 2. Understood this step, my children? Right. Plus c. This is the last step. That is why we added constant of integration. Understood, my children? Right. Now come to the question number 7. Next question. Integrate x into root of x plus 2. Integrate x into root of x plus 2. Okay, my children. Understood the question? Right. Now come to the solution part. Let us assume that capital letter I is equal to integral x into root of x plus 2 dx. Understood this step, my children? Right. Observe here, under the square root x plus 2 is there. The previous question also, what I told, in general we take the function which was given under the square root sign. That function can be taken for substitution. What is the function here under square root? X plus 2. So let us take x plus 2 for substitution. So put x plus 2. Put x plus 2 is equal to t. Understood this step, my children? Under the square root x plus 2, this function is there. So we take this function for substitution. Okay, my children, understood this step? Right. Now differentiating with respect to t. Differentiating with respect to t. This implies, what will you get here? What is the derivative of x? 1 only. 1. The derivative of this term is over. Now come to the second term. What is the derivative of root 2? 0. So I am not writing second term because plus 0. No need to write here. Into dx by dt is equal to, understood this LHS, my dear children? Right. Come to RHS. D by dt of t, 1. You have to calculate this entire part in your mind itself, my dear children. So we can write a direct step here. If you are master in this regard, if you are strong in the differentiation, then you can write this step directly. Okay, my dear children? Right. From this equation we find dx value. Okay, my dear children? Dx is equal to dx is equal to dt. We got dx value. But what about x here? Yes, we find the x value from this equation. Okay, my dear children. From this equation, what will get? X plus 2 is equal to t. We assumed here. Then what will you get? This implies x is equal to t minus 2. We converted this function also in terms of t. Okay, my children. This also converted into in terms of t. This term also converted into in terms of t. Okay, my children. Understood? Right. Therefore, I is equal to, what is x value here? We found here t minus 2. T minus 2. T minus 2 into square root of t plus x plus 2. What is x plus 2 here? T. Understood this term, my children? Understood this part? Right. Into dx. What is the dx value? dt. Understood this step, my children? We substituted x value t minus 2 here. Next to root x plus 2. Root x plus 2 means t here. Understood this part, my children? Next to dx. dx value is dt. By substituting all these three values, we got this step. Understood this step, my children? Right. That is equal to integral t minus 2. Again, we convert this radical sign into exponential form into dt, because root a can be written as a power 1 by 2. By using this property, we wrote this part. Understood this step, my children? Right. This is equal to integral. Now we use the distributive property. T into t power 1 by 2. T into t power 1 by 2 minus 2 into t power 1 by 2 whole dt. Understood this step, my children? We used here distributive property, then we got this step. Okay, my children? Understood? Right. Now if you observe this, now let us simplify this part also. That is equal to integral. This is in the form of a power m into a power n. A power m plus n, loss of exponents. So t power 1 plus 1 by 2. Here t power is 1. Understood this part, my children? Right. Minus 2 into t power 1 by 2 dt. Because a power m into a power n is equal to a power m plus n. By using this loss of exponents, I wrote this first term. We wrote second term as it is. Understood this first term, my children? Right. See here, we got integral t power 1 plus 1 by 2 minus 2 into t power 1 by 2 whole dt. Okay, my children. Now let us simplify this first term. What will you get here? Integral what you will get? 2 ones 2 plus 1 3 by 2 t power 3 by 2. We get here first term is t power 3 by 2. Understood this first term, my children? Right. Minus 2 t power 1 by 2 dt. We wrote the second term as it is. Understood this step, my children? Right. If you observe this integrand, it has two terms. First term is t power 3 by 2 and second term is minus 2 t power 1 by 2. So we can find integrals of these two terms separately. So I am splitting into two integrals. So integral t power 3 by 2 dt. I am writing here directly, numerical coefficient is 2. So 2 into integral t power 1 by 2 dt. Understood this step, my children? We have split into two integrals. At the same time, I wrote the numerical coefficient before the integral sign. Understood this step, my dear children? Right. Now if you come to the first term, it is in the form of integral x to the power of n dx. Isn't it or not, my dear children? Right. So we use that integral formula. Here also same formula. Okay, my dear children? Right. That is equal to t power 3 by 2 plus 1 by 3 by 2 plus 1 minus 2 into, here also it is in the form of integral x to the power of n, where x is equal to t and n is equal to 1 by 2. So t power 1 by 2 plus 1 by 2 plus 1, because integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. By using this formula, we wrote these two terms. Understood this step, my children? Right. Integration part is over. Now we have to write the terms in their simplest forms. Okay, my children? Right. That is equal to t power, what will you get here? 3 by 2 plus 1. 2 ones 2 plus 3. What will you get? 5 by 2 by, understood the numerator part, my children? Right. Here in the denominator also we get 5 by 2. Understood this denominator, my children? Right. Minus 2 into t power 1 by 2 plus 1. 2 ones 2 plus 1. 3 by 2 by, understood this numerator, my dear children? Right. Now come to denominator. We get the same 3 by 2. Understood this denominator, my dear children? Understood this step? Right. This is equal to, in the denominator 5 by 2 is there, then we write here it's a reciprocal. So 2 by 5, t power 5 by 2. This is the first term. Understood this first term, my dear children? Right. Minus 2 into, here 3 by 2 is there, we write it's reciprocal, 2 by 3 into t power 3 by 2. Understood this is second term, my children? Right. That is equal to 2 by 5 t power 5 by 2 minus 2 2s are 4, 4 by 3 t power 3 by 2. So we wrote the terms in their simplest forms. In this step, we wrote all the terms in their simplest forms. Understood this step, my children? Right. Now we substitute t value. What is assumed as t here? Yes, x plus 2. So 2 by 5 x plus 2 whole to the power of 5 by 2 minus 4 by 3 x plus 2 whole to the power of 3 by 2. This is the last step. So at last step, what should we do? Yes, we have to add constant of integration plus c. So this is the integral of the given function. Okay, my children, if you want to check this answer is correct or not, then differentiate this function. Then you get the given question. Okay, my children, understood? Right. Now come to the question number 10. Question number 10. Here I am not explaining question number 8 and question number 9, because question number 8 and question number 9 are the same that of question number 7. Square root sign is there. Under square root sign, whatever the function is there, substitute that function as t. Then you proceed. Okay, my children. Will you try yourself the question number 8 and question number 9, my children? Same as that of question number 7. Follow the same procedure. Okay, my children? Right. Now come to the question number 10. Integrate 1 by x minus root x. Okay, my children, understood this question? Right. Now come to the solution part. Let us assume that capital letter I is equal to integral 1 by x minus root x dx. Okay, my children? Right. Now before going to take the substitution, we have to modify the given function. Okay, my children? Right. This is equal to integral 1 by x can be written as root x into root x. Isn't it or not, my children? root x into root x. What will you get? X only. So for our convenient, we are writing x as root x into root x minus root x dx. We are modifying the given function according to our convenient. Okay, my children, understood this step? Right. This is equal to integral 1 by, I am taking root x from these two terms. We are taking the common factor root x. Then what will you get here? Root x minus 1 dx. Understood this part, my children? Right. Now we take the substitution. Which function? We have to take this function for substitution. Root x minus 1 can be taken for substitution. So put root x minus 1 is equal to t. Okay, my children? Right. Now differentiating with respect to t. Differentiating with respect to t. Then here two terms are there. What is the derivative of this root x? Yes, 1 by 2 root x. 1 by 2 root x minus, come to the second one, derivative of the constant term is 0. So I am not writing the 0 here, into dx by dt is equal to derivative of t is 1. Okay, my children, understood this step? I wrote this step directly. From this step, we find dx by root x value. We have substituted this function for t. We have taken this function for t. So dx by root x is there. So from this equation, let us find dx by root x value. So dx by root x is equal to, what will you get here? 2 dt. We are transposing this part to RHS, then it becomes 2 dt. Understood this step, my children? Right. Now we substitute this value and this value in the given integral. Okay, my children? Right. Therefore, I is equal to integral, first we take this one, 1 by root x minus 1. So 1 by root x minus 1 is taken as t. So we write it as denominator because it is in the denominator. So 1 by t. Understood this part, my children? Right. Into dx by root x is there. What is the value of dx by root x? 2 dt. Understood this part, my children? 2 dt. Right. Now here, if you observe 2 is a numerical coefficient, we write this 2 before the integral sign. So 2 integral 1 by t dt. Now if you observe, it is in the standard form. Integral 1 by x dx. Yes, log mod x. Isn't it or not, my children? Right. That is equal to 2 log mod t. Integral part is over. Integral part is over. Now we have to simplify this function. That is equal to 2 log mod, what is the t value here? Root x minus 1. Root x minus 1. So this is the last step. So at last step we have to add constant of integration plus c. Understood the last step, my dear children? Right. Now see here, my dear children, I am giving some hints. With the help of these hints, you can convert the given integral into the standard forms. Okay, my dear children. See here, for the eighth question, take this function 1 plus 2x square is equal to t and then proceed as we followed for the previous questions. We follow the same procedure. Okay, my dear children. Come to the question number 9. Put x square plus x plus 1. It is under the square root. If you observe the question, under the square root, this function is given. So we have to take this function for substitution. So x square plus x plus 1 is equal to t. And after that, you proceed the same steps as we followed for the previous questions. Okay, my dear children. Similarly, come to the question number 11. I will explain question number 10. Okay, my dear children. Because we have to modify the given function. That is why I have not given hint for the question number 10. Now question number 11, we can take directly x plus 4 is equal to t. Take this function for substitution, that is equal to t. Then you proceed, take the derivative of the function on both sides with respect to t. After that, substitute the given values. As we followed the steps for the previous questions, you follow the same steps. Okay, my children, understood? Right. Now question number 12. Put x cube minus 1, because x cube minus 1 whole to the power of 1 by 3 is a radical sign. So under the radical sign function is this one. So we take this function for substitution. So x cube minus 1 is equal to t, and proceed. Question number 13. Put 2 plus 3x cube is equal to t. Take this function for substitution. In the integrand, this is there. So we take this part of that integrand as t. Now come to the 14th question. Put log x is equal to t. Okay, my children, take this function for substitution. Next question number 15. 9 minus 4x square. If you observe, this is in the denominator. So I told you, sometimes we take a denominator function can be taken for substitution. So we take here this function for substitution. Question number 16. 2 plus 2x plus 3. 2x plus 3. It is e power 2x plus 3 there. So this function taken for substitution. Then it converts into standard form. Now question number 17. Put x square is equal to t. X square is equal to t, because e power x square is there in the denominator, e power x square. So x square taken as for substitution, and proceed. Next 18th question. Tan inverse of x is equal to t. Take tan inverse of x. Next question number 19. I did not give the hint because there is some modification is there. So directly we can't take any part of that integrand for substitution. That is why I have not given hint for the question number 19 also. Question number 20. Put e power 2x plus e power minus 2x is equal to t. In the integrand, this is in the denominator. Observe that given function. So we took this function for substitution. See question number 21. 2x minus 3 is equal to t. Take this function for substitution and proceed to find the integral. Question number 22. Put 7 minus 4x is equal to t. Take this function for substitution and you proceed the same steps. Question number 23. Put the sin inverse x is equal to t. Okay, my children, by using these hints, you can convert the given integral into the standard forms. Okay, my children. Now question number 24. Put 2 sin x plus 3 cos x is equal to t. In the denominator, actually 4 sin x plus 6 cos x is there. Take 2 common factor, then we get 2 sin x plus 3 cos x. Then they take this function for substitution. Okay, my children. Right. Question number 25. 1 minus tan x is equal to t. Take 1 minus tan x is equal to t. Question number 26. Root x is equal to t. Put root x is equal to t. Question number 27. Put 1 plus sin x is equal to t. Okay, my children. By taking these functions for substitutions, we can convert the given integrals into the standard forms. Okay, my children. But actually, you have to identify, you have to guess the suitable function for substitution by seeing the given integral. By practice, you can master in this regard. Okay, my children. Understood? Right. Now, question number 27. Okay, my children, by mistake I wrote 1 plus sin x. Not 1 plus sin x. Sin 2x is there. In the given question, 1 plus sin x is there. Sin 2x is there in the 27th question. So, put sin 2x is equal to t and proceed. Actually, that is question number 28. In the question number 28, 1 plus sin x is there in the given integrand. Whatever the function is there in the given integrand. From that integrand only we have to take some part for substitution. So in the question number 28, 1 plus sin x is there. So 1 plus sin x is equal to t. Put this, take this function for substitution. Okay, my children, understood? Right. Now come to the question number 29. Put log sin x is equal to t. Take this function for substitution. Similarly, question number 30. Put 1 plus cos x is equal to t. Okay, my children. Question number 31. For question number 31 also, put 1 plus cos x is equal to t and proceed. Question number 32, 33, 34. Some modifications are there. So, I did not give hints for that questions. Question number 35. Put 1 plus log x is equal to t. Okay, my children. Question number 36. Put x plus log x is equal to t. And question number 37. Put tan inverse x power 4 is equal to t. By taking these functions for substitutions in the given integrand, we can convert the given integrals in the standard forms. Then we can easily find integral of the functions. Okay, my dear children, this is about integration by substitution. We have to guess which part of the integrand should be taken for substitution. That is a very, very important thing. Okay, my dear children, understood? Right.